Hello and welcome to this new tutorial. In this tutorial, we will see how to detect objects using Mask R-CNN pre-trained model. So the first thing that I need to do is to download the pre-trained Mask R-CNN model. So we can go and search for Mask R-CNN, and this is one of the best libraries that can be used for object detection. I'm going to this GitHub, the original author's web page, and you can see some description here. I am interested in the pre-trained model, and there is an installation instruction available. So we have some pre-trained model which we can download them, and this is the latest version, and you can download them from here. But this reading this hierarchical data format is a little difficult. Maybe we can use some libraries, but an alternative way that I want to show you is to use this Mask R-CNN from the Learn OpenCV's website, and there is a link available from Dr. Satya's this website. We can go to, you can just read this in details if you want. The only thing that I need is to download in this TensorFlow PB format so that I can easily read this data or pre-trained model into my Emgu.CV. So I'm going to go ahead and copy this link. I will also provide this link in the description, and then click here to download this pre-trained model. Okay, so the download is complete. We can go ahead and extract it. Inside this folder, we need the pre-trained model. So I'm just going to copy this .pb, that is what I actually need, and I can create a new folder here. You can put anywhere you want, Mask R-CNN. So this is the pre-trained model that I am going to use. The other things that actually I need are the class names as well as the configuration file information. So we can get those configuration information. We can go to OpenCV GitHub. We can go to OpenCV. We can go to the main branch, and inside it, if you go down here, there is an OpenCV_extra, and inside this test data, you will see there is a DNN. And within this one, I need this file mask R-CNN inception_version2, this COCOM trained configuration information. So I just need to click on that, and you can open it as a raw file, and then you can save it. I just want to save it in the same location where I just created this mask R-CNN, and I just need to make sure that its extension is PB text. So I'm just going to save it here. And the last thing that I need is the name of my labels. So I'm just going to get those names so that we can display them. We can download the COCO dataset label names by searching for COCO labels. And we can go to this author's website, and then you can see here the COCO label names are available. We can click on that, and we can download it as a raw file. So I'm going to save as, and just let's keep it in the same folder. So COCO labels dot, let's say names, whatever you want to give extension, it's not a problem. So I'm going to save it. So these three files are needed. The label names, which we want to show them, the configuration, the trained model, and also the network configuration. So let us go ahead, create a new project, and try to load this model and do the object detection and segmentation. I already configured this project to use Emgu.CV 4.5, and inside this menu item, I'm going to add another item. And inside this process, in the drop-down collections, I can add a new item. We can name it like object detection mask R-CNN. I just copy the same text and paste it in the name and remove the spaces to make it a valid name, and click OK. And from the events, I'm going to select the events, and I'm going to select the object detection and then define a click event for that menu item. Here I will write a try catch block so that we don't have any issues with some errors. And the first thing I will do is where is my model? I need to define the model path. I will put an @ so that the special characters will be skipped, and I also need the configuration path for the model. That is also I'm writing @ and I will paste them. And also we need the Coco names. Where are the class names? So I just downloaded all these 3 files, so I'm going to read them one by one. So this is the path for the Coco names, so I write it in the correct place, and I need the trained model, so I just copy the path of my model. You can put anywhere you want, and also the network architecture, so I'm just going to copy that and then place it here. So the required files are here. Now we can go ahead and load the pre-trained mask R-CNN model. So let me create a variable called net, and we can use CvInvoke dot. Remember, I'm going to read from a TensorFlow model, so I'm going to read net from TensorFlow. So if you have a TensorFlow, then there is a specific method, and here we can pass the model path. This is the model path, and the second parameter will be our network architecture, which is in config path variable. So this method will load our model, and we can also define the backend for our model. So I'm going to use this OpenCV as the backend here for this model to run. And if you want to set, for example, since I'm going to use the CPU, so I need to mention the target that if you are using CUDA or any other, you can mention it as well. So the model is ready by now, and since I need to display the names, so let me read them also. So we can give it a name like classes is equal to, we can use this file dot. This file is not present here, so actually it is present inside the system.io. So I need to add this line. So now it can show me, if we want to read all the lines, we can use this read lines method from a text file, and here I can provide the path, so Coco names. Okay, so our model is now ready, and the first thing that I should do is to make sure that we read an image. So I'm going to write if not img dict, and if it doesn't contain dot contains key, for example, and if we have not read an input image, which I assume that we have read earlier, then we can throw an exception. Throw new exception, read an image first. So if we have an image, then I can read it into a variable from this img dict. So the name of the dict is input, and let me create a clone. And to suppress some noise, we can apply a smooth Gaussian if you want, with a small kernel. Okay. And this image cannot be directly taken as input into the network, so we need to convert it into a tensor or the binary large object, in which we can easily do by calling this blog from image. and we can pass this image as input. If you want to scale it, you can use the scaling. Right now I'm using 1.00, and the size that we want to provide as input is the same as the size of our input image. And for the TensorFlow, we actually need to swap the red and the blue channels. So what I will do, I will only set the swap R and B to be true, and the rest of the parameters will be as default. And now what we can do is once our tensor is ready and our model is also ready, then we can put the input for it. So we can use this method set input, and this is the blob that we want to take it as an input. And now we want to pass this blob through the layers, and we want to get the outputs. So this mask RNN will give us two outputs. One is what we call it the bounding boxes, and the other is the masks. So we are right now interested in the bounding boxes. So two outputs will be obtained. What we can do is we can create a vector of mates, because there will be two mates. Vector of mates, we can create them. We call it output. New vector of mates. So there will be two mates, one for the masks and one for the bounding boxes for the objects that we have detected, and we will store them in this output. And we also need to define the outputs that we want from which layers. So string, we can create a name of those layers. Remember that these names must be written exactly the same way as I'm writing here, because those are the names, fixed names. The first output that I want and the second output. The first output is detection underscore out underscore find. This is what the exact name exists in this layer. And the second output for the masks, detection underscore masks. Its name is detection underscore masks. Okay, so now we can get those bounding boxes. So let us go ahead and pass this blob and get those outputs. So we will use this forward method, and here the second overloaded method, you can see in fact, if you want, yes, this one I will use. The output, where you want to put the output, is the name of our object is the output, and which layers, name of the layers from which you want to get the outputs is we also provide the output names. So there are two layers from where we want to get the output. I just want to put a break here, and I want to show you what exactly we get from this output. Let us run it. Open an image and then apply object detection. It means there is no error, so let us run it by pressing F10, and we get the output. So when I check this output, you can see there are two mate objects. So of course one is for the bounding boxes and another is for the masks. So when you look at these bounding boxes, you can see here it is a 1 by 1 by 100 by 7. So there are 100 bounding boxes, those are obtained, and each bounding box has 7 information for each of them, which basically contains the information about the class ID, what is the class of this object, the left, top, right, and the bottom corners of the bounding box, as well as the score of the what is the percentage, what is the score or the confidence score. The confidence here is at this location. So we will extract these information, the required information from each bounding box, and try to display the bounding box around the object. So, and also if you look at the mask, or the second one is basically the mask. So this one indicates, again, since we have 100 bounding boxes, so for each bounding box we have a mask. And the second one is the 90, which indicates that we use the 90 classes. The COCO consisted of 90 classes, and each mask basically is a 15 by 15. I'm not going to exploit the mask, but I'm going to use the information of the bounding box, and we will try to draw those bounding boxes. So far so good. I'm going to extract the number of detections that we have. So for example, we can say number of detections. So from this output array, this is the 0th array or the second array, doesn't matter, we can get it. Size of dimension number 2 will give us the number of detections. And also we already know the number of classes. Number of classes is equal to this, the number of classes we can obtain from the first one or the second one. If you see that it was in the masks object, if we look at the dimension, the second one at the index 1 was actually the number of classes that showed was 90. And now I can easily process these mate. So what I will do is convert them into arrays, C# arrays, the boxes, we call them output. The boxes, the first one is the bounding boxes dot get data. I will do the copy and a paste. And similarly, we can do for the masks. This masks will be the first one. So there are two arrays. So I read those arrays. So let us go and loop through all those detections. So for I is equal to number of detections we have for each bounding box. And the first thing that I will do is to read the score. What was the confidence score? So we can get the B boxes dot get value, and we can get this value because it's a 4-dimensional array. First or 0 0, this will be the detection number, ith detection, and the value at the third index will give us the score. And we can make a condition that of course it can be converted into a float, and we can put a condition on, for example, if this score or if this confidence is greater than 0.5, that I'm pretty sure that this is an object, I want to apply a threshold, then we can display that. So to display that, as I mentioned, we need to first extract the class ID. So I need these information. So the class ID we can obtain by the bounding box dot get value, and this value will be present at for this ith bounding box at the second or the index 1. And since this needs to be an integer, so what I will do is I need to convert it into convert dot to int 32. I just want to convert this object into an int 32. So I get the class information. Now for the bounding box, I need the left, top, right, and the bottom information. So the left of the bounding box is also present in this. So I will use again, it will convert it into an integer. So to int 32, and we can read it in the same way. B boxes dot get value, 0th image, 0th ID, and this is the box, and it starts from the third index. And that's it. But you know, we need to scale this index so that we will fit into scale back into original image where we want to display them. So we need to multiply with the image dot number of columns that we have in the image. So this one will give us the left corner. So of course I need to convert this one into a float. Okay, so we obtained the left. Similarly, I will do just copy, and similarly we need to get the top and the right and the bottom. So I just copy, paste, 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 and let me rename to be right, top, and the bottom. So for the right, this information is on the 5th location. Actually, we should write it so that you should not be confused. Left, then comes the top, which is on the 4th, and this one is on the 6th index. And also here I need to multiply with the row, and this is also scaled by the number of rows, and that's it. And once we know the left, right, top, bottom of the a rectangle, we can go ahead and draw that rectangle. So rectangle, we can call it rectangle is equal to new rectangle. And for this one, we can provide the left, right, top, bottom. So left, we know it. The top, we know it. That will be the Y. And the width can be calculated by top minus right minus left plus 1. And the height can be calculated by the top minus bottom plus 1. In fact, I should do to make it a positive, bottom minus top. Okay, so once we have the rectangle, then we can draw this rectangle. Img.draw. And we want to draw this rectangle, and then we can give it color. So I want to give it color 0, 0, and 255. So it will be in red color. So we just draw the rectangle, and if you want, we can also draw the class label because we have the class ID already and the class names as well. So we can obtain those labels by using these classes and pass the index of this class ID. So from 0 to onwards, whatever the class we have. And then we can display CvInvoke.putText. And then we can display it img, the label that we have, and we want to put it at some point, so we can put it on this point left and the top, and to make it a little bit on above it, so we can put it minus so that we can display the label on top of this rectangle. And we can define a font face to be simplex, and I don't want to scale them. And we can give any color for this one. Let me give it green color 2550, and set its thickness to be 2, and then don't forget to put a semicolon. Let me divide this one into 2 lines. So this way we just put the text over here. And one problem can happen because it can go outside of the bounding rectangle. So to make sure it is not going beyond, it is not negative or beyond the border. So what I will do is left is equal to math.maximum, whichever is the maximum we will select between 0 and math.minimum of. We want to make sure whichever is the minimum, we need to select left, comma, img.columns minus 1. And we can also do the same thing for the right one. Here I will write right, and also here is the right. And for the top and the bottom as well. So I will do, in fact, let me do for top first. And here it will be top, and this is related to rows, so we need to do it rows. And it is the same for the bottom, so I copy and paste. Here we will do it for the bottom, so I just copy it and also paste it here. And that's it. So once we get the scores, I processed it, get the class ID, the left, right, top, and at the bottom of the rectangle, and then I try to display it. And we can go ahead outside this loop, and we can display the picture. So image is equal to img.2bitmap. Let me run this application. Okay, let me go and select an image, select this pedestrian, and try to do the object detection. Okay, it looks fine. So you can see that the truck has been identified, the person, the car. Let me try with another one. Open it, and let me try for this person. Okay, you can see that this has perfectly detected the person as well as the dog. So of course there are some shortcomings. For some it might work, and for some cases it might miss some object, but overall this is how we can use the Mask R-CNN to detect objects in images. Okay, hope to see you in another video.